Mixture. A mixture is a combination of two or more substances in any proportion. This is different from a compound, which consists of substances in fixed proportions. The substances in a mixture also do not combine chemically to form a new substance as they do in a compound. Instead, they just intermingle and keep their original properties. The lemonade is a mixture because it doesn't have fixed proportions of ingredients. It could have more or less lemon juice, for example, or more or less sugar, and it would still be lemonade. Other examples of liquid mixtures include salt, water solution, and sugar water solution. Air is a mixture of gases, mainly nitrogen and oxygen. A homogeneous mixture is a mixture in which the composition is uniform throughout the mixture. The salt-water solution is homogeneous mixture because the dissolved salt is evenly distributed throughout the entire salt-water solution. Homogeneous mixtures appear uniform to the eye. They consist of a single phase, be it liquid, gas, or solid, no matter where you sample them or how closely you examine them. A phase is any part of a sample that has a uniform composition and properties. By definition, a pure substance or a homogeneous mixture consists of a single phase. Heterogeneous mixtures. A heterogeneous mixture is a mixture in which the composition is not uniform throughout the mixture. Vegetable soup is a heterogeneous mixture. Any given spoonful of soup will contain varying amounts of the different vegetables and other components of the soup. If you take two samples from different parts of a heterogeneous mixture, they will not have an identical composition. You can use a mechanical method to separate components of a heterogeneous mixture. A heterogeneous mixture consists of two or more phases. When oil and water are combined, they do not mix evenly, but instead form two separate layers. Each of the layers is called a phase. Examples of heterogeneous mixtures. Sugar and sand form a heterogeneous mixture. If you look closely, you can identify tiny, sugar crystals and particles of sand. Salt and pepper form a heterogeneous mixture. Chocolate chip cookies are a heterogeneous mixture. If you take a bite from a cookie, you may not get the same number of chips as you get in another bite. Examples of homogeneous mixtures. The lemonade is an example of a homogeneous mixture. A homogeneous mixture has the same composition throughout. Another example of a homogeneous mixture is salt water. If you analyzed samples of ocean water in different places, you would find that the proportion of salt in each sample is the same. Types of mixtures. Mixtures have different properties depending on the size of their particles. Three types of mixtures based on particle size are solutions, suspensions, and colloids. Solutions. A solution is a homogeneous mixture with tiny particles. The particles are too small to see and also too small to settle or be filtered out of the mixture. When the salt is thoroughly mixed into the water, it will form a solution. The salt will no longer be visible in the water and it won't settle to the bottom of the glass. Colloids. A colloid is a homogeneous mixture with medium-sized particles. The particles are large enough to see but not large enough to settle or be filtered out of the mixture. The gelatin is a colloid. You can see the gelatin particles in the mixture. However, the particles are too small to settle to the bottom of a dish. Suspensions. A suspension is a heterogeneous mixture with large particles. The particles are large enough to see and also to settle or be filtered out of the mixture. The salad dressing is a suspension. It contains oil, vinegar, herbs, and spices. If the bottle sits undisturbed for very long, the mixture will separate into its component parts. That's why you should shake it before you use it. The paint is a suspension. Some of the components of the paint settle out of the mixture when it sits undisturbed for a long time. This explains why you need to shake or stir the paint before you use it. Homogenized milk is a colloid. The particles in the milk are large enough to see, that's why milk is white instead of clear like water, which is the main component of milk. However, the particles are not large enough to settle out of the mixture.